Hello everyone, welcome to MLAS650, and this week we are going to jump into a lab for code refactoring as it relates to autonomous systems. Now, code refactoring rather, is something that we can do in any industry and for any code environment, for any programming language. But you're probably wondering, like, what is it that we're going to be talking about here? And I'm going to just jump in high level. We'll do just a run through of what code refactoring means from a software perspective, and then how that relates to us on the autonomous system side of it with our microcontroller. And then from there, I'm going to do a little programming exercise to kind of give you an example of what code refactoring looks like at a really high level. Of course, we're going to be using our Mu editor and Python to go through that. So without further ado, let's go ahead and jump into what is code refactoring. So first up, code. Let's see if I can get my... let's see if I can get a better... there we go. Code refactoring. And this is going to be our starting point. So first up, the first thing is when we talk about code refactoring, what does that even mean? So the first thing is, as it relates to our programming code, it's going to be better readability. And so this is, this is the kind of the first step here in terms of what does it mean in terms of why. So read ability. So it's gonna make our code a lot easier to read. So of course, just like anything, like we were writing a book, easier to read book is more digestible. So the other thing that it does that is super helpful is reduced complexity. So we reduce complexity. And this is pretty important because as our code becomes more expansive, right? And it also means that anything that we can do to reduce complexity while still maintaining functionality, the same functionality, well, of course, why wouldn't we do that, right? It's more efficient. Third up is going to be maintainability. So we're going to improve maintainability. And this is number 3 on the list. Okay. And then number 4 is what we call technical debt, a reduction in technical debt. So this is going to be reduce tech debt. We'll just call it that, tech debt. Of course, less overhead means that these all work together, right? Better readability, reducing complexity, improving maintainability. Those are all in an effort to reduce the technical debt, the technical overhead, which also has an ability for the system. If we do all of this, it makes our autonomous system scale better. So that's another big reason why we want to do this. Another one is enhanced performance, right? Enhance performance. All right. And then extensibility. Increase, and let's just say increase scale. If that's a little hard to read there. Increase scale. Let's do that again. There we go. Now all of these are related to code refactoring. These are all super helpful, they're all needed, and overall this is exactly what we're trying to go for. So why is this important? I think the question is, the big one is, for autonomous systems, why is that important? Well, I mean, the big thing that you're going to have to come to terms with as it relates to anything that relates to autonomous systems is that, especially when you're talking about mobile robotics, when you're talking about spacecraft design, when you're talking about microcontroller architecture such as what we're working with, it's really important to maximize the efficiency of the hardware you're working on. So code refactoring is really a way of life when it comes to developing on code on autonomous systems. And you're going to actually, we actually come into this and we struggle with it. It's a real life struggle as it relates to the work we do on our microcontroller here. This guy doesn't have a lot of compute power, doesn't have a lot of memory, and it doesn't have a lot. It's not like a big PC where I can run a lot of different code and I can do a lot of different things. It's really hard to make, to do even simple tasks running on this. It can be a challenge. So let's go through and illustrate what is code refactoring and how this all kind of comes together. Okay, so let's move this out of the way. I'm going to minimize this here. I'll bring it back as we need to. I think we can get away with doing what we need to minimized on the side here. I think that should just about cover it. Okay, so let's go into I've connected up my microbit controller here. And no, sorry, not my microbit, my Adafruit controller. That's a different class. But yeah, this is what we're going to be, of course, connected to for this experiment. And I'm going to actually create a very simple program. And in this one, we're going to actually create a very, very, very simple program. And in this one, it's going to be, it's going to do some math. And what I'm gonna do is I'm gonna create some extra language around this. I'm gonna create a comment and I'm gonna say create a program to do some math. And then this is our simple program. And then I'm gonna create some variables. I'm gonna create some variables. And let me see if I can't create variables. Python variables, and I'm gonna actually do that. Get in here. There we go. Okay, and so then that way I've got, all right, perfect. Create some Python variables, and we're gonna create 3 Python variables. I'm gonna say number 1, number 2, number 3, and that should be enough. So this is going to be, and we can make it whatever we want, like this. And then we're going to say do some math. Okay, and in this case, I'm going to do a print of number 1, and then I'm going to say number 1. I'm going to add it to number 2. And then I'm going to say take the output of that and divide it by number 3. And I think that's all I need. And this is our simple program. This is it. Now you're probably wondering, like, how are we going to refactor this? But that's what we're going to try. We're going to keep it super simple. So, and we're just going to, it's going to be a print screen to this. So when I run this, you're going to get your, it's going to beep like that, give us a green, tells us that it ran. And then you're actually going to get a run of the program that should give you on your, you'll actually, it's very small. It's going to be tiny on this thing, and it's not going to come through very cleanly. But you're going to see the output here. It's going to be 0.142001. It's going to be right here on your screen, your TFT gizmo. And that's just the console, the console, the serial output right here that you're going to see over here. That should, everything that you see on here is going to replicate on this console. Or rather the serial output will replicate as a console output on the Adafruit TFT gizmo. Okay, so that's our simple program. That's all we're going to do. Now, this is a non, I'm going to say create that, and then I'm going to put some extra here. I'm going to put a string literal on this, and I'm going to say like this. I'm going to say this is not, this program is not refactored. Okay, so there you go. That's I think this will give us everything I need to give you an example of what is code refactoring in this context with our simple example here. And this is actually going to lead into us revising our code for our TFT gizmo and getting this all set up from our last example. And so what we're going to do is now refactor this code. Okay, so this is something you'll have to take a copy of, and then what we're going to do now is refactor code. So now I'm going to simplify this. Remember when we talked about this, we talked about better readability, we talked about reduced complexity, improve maintainability, enhance performance, reduce tech debt, and increase scale. So we are going to reduce complexity. I think of all of these things on here, reducing the complexity helps to benefit all the others, which also helps to reduce the tech debt. So in this case, I'm going to reduce complexity. And to do that, well, do we need all these extra comments in here? Do our comments need to be this expansive? Well, probably not. So I'm going to say create create math program, and that's it. That's the only comment I'm going to have. And then I'm going to remove this string literal. I'm going to make this smaller. And do I need to actually have these Python variables listed this way? Probably not, so I can get rid of those too. Okay, and then now what we can do is we can take the variables. So each line, although it's not a ton, but each line of code is an extra line that has to be taken up in memory. So I'm actually going to simplify this even more. One of the neat things that you can do in Python is I can put all these variables on a single line. And then what I can do is then I don't even need this. I can do that. So this now went from about 9 lines of code to then 3 lines of code. And technically, I don't even need that. But it is kind of helpful to have some kind of comment structure, but just a very minimal amount of comment structure is really all we need. So let's test it out and let's see. Now we've refactored this code and we should get the same output, which in fact we do. So if you look on your TFT gizmo, you should get a 142001 output, which means that we do have the same output here. And what's really nice about this is we took a larger program and we scrunched it down into a smaller, more simplified program. And that is the essence of making this explaining rather what code refactoring is in this context. So we reduced the back here, right? Just as a quick overview, we make this a little bit bigger so that people can see this. So we reduced, we made it more readable, right? We simplified it. We reduced the complexity, simplifying it again. This is definitely going to be easier to maintain because, again, remember, we're now down to 3 lines of code versus 9 lines of code, which makes this so much easier to maintain. This also, because we reduced the tech debt, you're probably wondering, like, what's the example here in this? Well, it's memory. So this uses less memory than if I had 9 lines of code versus 3 lines of code. There's more that's involved with that, but just high level, a reduction, refactoring a code and reducing the amount of code, and reducing the complexity usually has is inversely related to the amount of memory the computer is going to use. So in other words, it frees up the memory, so it increases how much memory is available. So the lower amount of code I have, the more performance I'm going to have usually, and usually the less memory I'm going to be using. Now that's not always the case. I don't want to get into special cases and whatnot, but that should be high level. That's a good general rule. And then because we reduced the code that we have over here, that also increases our ability to scale this. Now, this is all important as it relates to an autonomous system, because if we make it more memory efficient, we make it more readable, we reduce the complexity, we enhance its performance, that all comes together and allows us to run something on a smaller footprint. Right, because if I'm creating a control system, let's say for a satellite system, well, I very well can't fit a big giant computer in it, versus if I can fit something like this. This is way easier to maintain and manage, and the power consumption too, right? The power consumption to use something like this as a control system for a satellite is going to be so much more advantageous, because this is a lot less for me to lift into orbit, right? The physics of lifting this into orbit is so much easier than, from an expenditure perspective, than trying to lift like a 30-pound computer into space. That takes a lot more. It takes a lot more effort, and so that's really where it comes down to autonomous systems. When we're talking about autonomous systems, we're talking about creating control systems that are extremely efficient. Okay, I think that's all I got for this one. That's our first lab. I'm gonna now our second lab that we're gonna go into this week is gonna be actually refactoring our code and putting it into practice. So that's it for this one, and I will see you in the next lab.